This lesson helps you understand the rules for transformations and how they affect the absolute value function. In a previous lesson, you graphed the absolute value function and several variations of the function. In this lesson, you're going to use these graphs to learn and understand the rules for transformations. This is important because these rules apply to any function. The graph of an absolute value function is a V-shaped figure opening upward. The base of the V is called the vertex. The lines on either side of the vertex are the legs. The right leg has a slope equal to +1. The left leg has a slope equal to -1. For this function, x was replaced with x minus 2. If you did it correctly, you can see the graph shifted 2 units to the right. The vertex is now at +2 on the x-axis. Think about this carefully. It would be natural to think x minus 2 would shift the graph to the left, since left is the negative direction on the x-axis. But the opposite is true. For this function, x was replaced by x plus 1. The graph shifted 1 unit to the left, and the vertex is now at -1 on the x-axis. So here's the rule. If you replace x with x minus h, the graph shifts h units to the right. If you replace x with x plus h, the graph shifts h units left. For this graph, 1 was added to the function. The y-coordinate of every point was increased by 1, and the graph shifted up 1 unit. The vertex is now at +1 on the y-axis. For this graph, 2 was subtracted from the function. The y-coordinate of every point was decreased by 2, and the graph shifted 2 units down. The vertex is now at -2 on the y-axis. So here's the rule. If you add k units to the function, the graph shifts k units up. If you subtract k units from the function, the graph shifts k units down. These shifts, right, left, up, and down, are called translations. For this graph, the function was multiplied by -1. The y-coordinate of every point was multiplied by -1, and the graph flipped over and opens down. This is called a vertical reflection. For this graph, the function was multiplied by 2. The graph stretches vertically, and the legs now have slopes equal to ±2 instead of ±1. For this graph, the function was multiplied by 1/2. The graph shrinks vertically, and the legs now have slopes equal to ±1/2 instead of ±1. So here's the rule. When you multiply the function by a number greater than 1, the graph stretches vertically, and the slope of the legs increase. When you multiply the function by a number less than 1, the graph shrinks vertically, and the slope of the legs decrease. This type of transformation is called a dilation. This lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.